Hello class, welcome back to another section of our intensive calculus course. We are still on applications of differentiation. In this class, we are going to look at Rolle's theorem and mean value theorem. These are some important theorems we have in calculus which use to solve varieties of problems. Kindly watch this video to the end so that you understand every part of the video. Give me a thumbs up by subscribing to this channel. Don't forget to like, subscribe, and also share. Rolle's theorem. Rolle's theorem is a theorem in calculus which says that if you have a continuous function, so let's say I have a function here, this is my plane. I have a function which is continuous on an interval AB and also differentiable on that interval, in that there is no break. That's all that I mean. And provided this function has f of a to be equal to f of b, that is, the functional value of the endpoints are the same. If I have the function f of x and I find f of a, I should get f of b. Therefore, the graph will be represented as something starting from here, which moves and ends somewhere here, because these points A and B, they are on the same ground, right? So if all these conditions are satisfied, condition 1, the function should be continuous on this, there shouldn't be any break. Condition 2, it should be differentiable, and you know once it is differentiable to be continuous, yes. Now condition 3 is f of A should be equal to f of B. Then if all these are satisfied, what the theorem is saying is there is a particular number c which is a member of this interval AB, so that if you find f prime of c, we are going to get 0. If you find f prime of c, we will get 0. This is how this theorem is represented. So this theorem can give you a function, say 2x, but normally for you to get a question from this, the question must satisfy all the conditions and it's quite difficult. So let's proceed to the mean value theorem. Mean value theorem. When you see mean is finding the average of a set of letters, a set of numbers we have in a system. Let me draw a graph here. If you have a graph and the function defined on a particular interval AB, where it is also continuous, is also what? Continuous, and differentiable as well. Therefore, in this theorem, f of A should not be equal to f of B. It's not like there's no need for it to be equal to, like the Rolle's theorem. In this theorem, f of A is different from f of B, and even yes, should not be equal to. It shouldn't be equal to f of b. Once it's equal to, we get the Rolle's theorem. So you can say that the Rolle's theorem is a modified form of the mean value theorem. Let's see the mean value theorem very well. So what I'm saying is, if your f of a, this interval a and b, if they are not giving the same functional value, I'll assume a will give a small value here and this will give a value here. Then I'll have my function this way. And when I have this, what the mean value theorem is saying is that there is a particular number c, so that f prime of c is always equal to f of b minus f of a all over b minus a, which happens to be the gradient function. So all that is trying to say is that there is a particular c which will satisfy this gradient function we have here. So you can see clearly that if your f of a is equal to your f of b, then you get the mean value theorem. Here will be 0. Sorry, here it doesn't necessarily mean in the mean value theorem, a should not be equal to 0 rather, but f of a, if it happens to be equal to f of b, we get the Rolle's theorem. But normally f of a is always different from f of what? B. So this doesn't hold. So in the mean value theorem, f of b is different from f of a. If it becomes equal, you get the Rolle's theorem. But if they are different, this is a representation, your a and your b. But the a and the b should not be the same, because if they are the same, you will get an undefined expression. Let's take a question so that you see the relevance of these theorems. Determine all numbers c which satisfy the conclusion on the mean value theorem for the function f of x, which is equal to x cubed plus 2x squared minus x on the interval -1, 2. So we can see that we have our interval here, and they've given us a function so that we find the value c for which the mean value theorem will hold. We come f prime of c, we state is equal to f of b minus f of a all over what? B minus a. After stating this, what do? We find f prime, then you put c in it. So my f prime of x actually is going to be 3x squared plus 4x minus 1. Once I find this, I find my f prime of c, which is simply 3c squared plus 4c minus what? 1. Then they are saying that 3c squared plus 4c minus 1 should be equal to f of b. What will be my f of b? My b is 2. F of 2 in this function, 2 to the power 3 will be 8. 8 plus 2 open brackets, 2 to the power 2 minus 2. So 8 here will be 4, 8, 16 minus 2, we get 14. Minus f of -1. This will be -1 cubed plus 2 open bracket -1 all squared, then minus 1, so plus 1. So I get -1 plus 2, 1 plus 2, 2 all over 2 minus 1, so 2 plus 1. So I'll get 3c squared plus 4c minus 1 is equal to 12 over 3. So 3c squared plus 4c minus 1 will be equal to 4. My 3c squared plus 4c, then I'll get minus 5 is equal to 0. So I need the values of c, and that will be my solution. So if I have this 3, then I have 4, and I have -5. So my c, I have c1 to be equal to 0.786, my c2 to be equal to -2.12. This is simply how we go by finding c in the mean values theorem, and the same holds for the Rolle's theorem. Thanks for joining this class. See you in the next class. Don't forget to like, share, and also subscribe.